All right, we're going to go ahead and get started. As always, if you guys got questions along the way, stop me, come off mute. You can go in the group chat. Either way, it doesn't matter to me. This week is all about operating systems. And so we'll get started here today with the Windows operating system. You'll notice some other stuff pop up out here on Blackboard by the end of today. But for the Windows operating system, a couple things that this particular module is going to cover is the history of the Windows operating system, a little bit about the architecture, and we'll use that as a comparison and contrast on Wednesday with Linux, and explain how to configure and monitor Windows and then how it can be kept secure. So there's quite a bit into this particular module. So starting off with Windows history. It started out with the DOS operating system. I'm not sure how many of you guys actually played with this, but back in the day, we had a DOS operating system that was used to enable people to have access to storage devices and read and write files. DOS provided that file system, which organized files in a specific way. Later on, you had MS-DOS, which was created by Microsoft, used as a command line interface for people to create programs and manipulate data files. DOS commands are shown in bold text, as you see over there to the right, with the given command, being this one here. So like running smartdrive.exe with a /x extension on there, and then running dir so that you could list everything that was in that particular folder. The computer had a basic working knowledge of accessing a disk drive and loading operating system files directly from the disk as part of the boot process. So this was a very early operating system. It's actually one that I got started on prior to Windows 3.11 and did quite a few things in Microsoft DOS system. It was all command line like this, so there was no fancy GUI or anything like that back then. The earlier versions of Windows consisted of a GUI that we talked about there before, which ran over the top of MS-DOS, which started with Windows 1.0 in 1985. The newer versions of Windows were built on, quote, new technologies, or the NT version of the operating system, direct control of the hardware and the computer itself. So today, many things are accomplished through the command line interface of MS-DOS and can be accomplished through the Windows GUI. So to experience a little bit of MS-DOS, you can type in the CMD in the Windows search and hit enter, and you'll end up getting the command prompt. And that'll look something like this here, which I was actually in the DNS request. So let me clear this out. Let me just click this. So this here is the equivalent, a little bit of what you would have saw in the MS-DOS world, only this was all you got. You didn't get it as a GUI with a nice terminal and copy and paste and everything else in between. All right, so there's some basic commands of MS-DOS, and these still work within the command line today. You have dir, which is what shows a listing of all the files in the current directory or the folder. CD for directory, this is change directory to whatever one you specify. If you want to go back one directory, you can use cd ... If you want to go back to the root directory, which is often referred to as the C drive, you would go cd/. You can use the copy command where you type copy, you have the source file, and then you have a destination file. On this source file, you're typically in the same folder that you are writing it from, so you don't have to have the absolute path for this. You can use the relative path, but this has generally got to be the absolute path, but you can also use the relative type path here as well. Del file name deletes a file name. Find will search for text. mkdir will change or create a new directory, rather, make directory. Rename or ren will allow you to rename a file, and then help and help command. So just some common ones that were used on the command line that you would even use today. In 1993, there have been since 1993, there have been about 20 releases of Windows that are based on the NT operating system. Many additions were built specifically for workstation, professional, server, advanced server, data center server, just to name a few. And those were kind of purpose-built versions for those particular systems. When the 64-bit operating system was an entirely new architecture, and it was a 64 address space instead of the 32. 64-bit computers and operating systems are backward compatible with the old 32-bit programs, but your 64-bit programs cannot run on the older 32-bit hardware. And as such, with each subsequent release of Windows, the Windows operating system has become more refined by incorporating more features. And so Windows 10 will actually be the last version of Windows. So instead of purchasing entirely new operating systems, users will just update to a newer version of Windows 10. That's kind of their model from here on out. Here are some pretty common versions. You had Windows 7, you had Windows Server 2008 R2. That was a really popular one for servers. Windows Home Server. Home Server was popular for data storage management at your house. So you have a whole bunch of these little NAS devices out there today, but Home Server was one of the first ones that was pretty popular for that. Windows 8, many of you are familiar with, in 8.1, which my eyes were pretty much a flop, but that's just me personal. Windows Server 2012 is an extremely popular one. 2012 R2 is still pretty much in session today. Windows 2000 or 2010, as we all know it, and then Server 2016. We now have up to like Server 2019, etc. As you know, Windows 7 just recently expired in terms of updates and things like that. They believe that happened back in February. So everybody should be running 8 or to 10, and you can upgrade to 10 for free, so it's not that bad. Okay, so the Windows GUI itself, the GUI is the main area of the desktop, known as the desktop, and it can be customized with various colors, background images, etc. Windows supports multiple users, so each user can customize their desktop. Desktop can store files, folders, shortcuts to locations, programs, applications, etc. The desktop itself has a recycle bin, which is where most people find files that they want to truly delete. So some main areas of the GUI, I'm assuming most of you are familiar with this, but just as a recovery or a recap, this is your desktop area. You have the main taskbar. You have the start button over here with the menu search. You have your quick launch icons and then your notification area over here. Your taskbar will also show up with programs as they start to load across here. And as they mentioned here, these are all the specifics of the icons and such that I just gave you. All right, so right-clicking an icon can usually bring up additional functions. For example, here's a context menu for PowerPoint. The context menus are known for their icons, and notification area, quick launch buttons, etc. And that context menu provides with most commonly used functions just by a single click. Operating systems consist of millions of lines of code. With all this code becomes vulnerabilities. A vulnerability is some flaw or a weakness that can be exploited by an attacker to reduce the viability of the computer's information. To take advantage of that operating system vulnerability, the attacker must use a technique or a tool to exploit that vulnerability. An attacker can use the vulnerability to get the computer to act in a fashion outside of its intended design. And in general, the goal is to gain unauthorized content or control of the system itself, change permissions, manipulate data, or steal data. So some key words you guys will need to know, especially within the Windows OS. Virus and malware protection. By default, Windows will use Windows Defender for its malware protection. Windows Defender provides a suite of protection tools rather, built into the system. And if Windows Defender is turned off, the system is more vulnerable to attacks and malware. Some unknown or managed services. There's many services that run behind the scene. It's important to check each service is identifiable and safe. And with an unknown service running in the background, the computer can be vulnerable to attack. You can use Task Manager to do this if you wanted to. We'll cover this in a little bit more detail, but Task Manager looks like, I get it to load here real quick on the Windows 10 system. Must be hiding it behind another screen somewhere. There we go. And so this is your Windows 10 on this particular system. So you'll see I have a bunch of different programs running all the way through here. You'll see you can run your performance and find out what your current operating system's running at, app history, your startup details, etc. Let's see here. Encryption, when data is not encrypted, is easily gathered and exploited. This is not only important for desktop computers, but especially mobile devices. And a good security policy must be configured and followed. Many settings within the Windows security policy control and prevent attacks. The firewall, by default, Windows uses the Windows Firewall to limit communication on devices on the network. Over time, rules may no longer apply. It's important for you to review those firewall settings periodically and make sure that those rules are still applicable and remove any that are not. So if you installed some software and opened up some holes in your firewall, in order for those applications to work correctly, you need to kind of go back and make sure it cleaned them up when you were done. File share permissions. Permissions must set be correctly. It's easy to give everybody a group of full control, and that allows all people to access all the files. However, it is best to provide each user or group with the minimum necessary permissions for all files and folders needed. We'll dive into this in much more detail. From a weak or no password, hopefully you guys have gotten this far, you know quite a bit about passwords, but the idea that many people using weak passwords or no password at all, it's a bad thing. It's especially important to make sure that all accounts, especially the administrator account, have a very strong password. And what classifies as a strong password changes among different people, whether that's must have an uppercase, lowercase, special characters, numbers, etc. But quite frankly, after years of password cracking, etc., the length of the password is what really matters. It's what really matters. So definitely try to keep a longer password, which is generally done by using a phrase of some sort. You can replace some characters along the way, but having a good solid phrase is a good way to go. When you log in as an administrator, any programs that run will have privileges of that account, and therefore it's best to log in as a standard user and just use the administrator password to accomplish certain tasks. And some of you have seen this when you install software in Windows. It may ask to have administrator privileges. That is the better way, other than logging in as administrator and just making sure everything works. All right, so now we're going to talk a little bit about the architecture and how it operates. So from a hardware abstraction layer, which is referred to as the HAL, its software is handled between communication of the hardware and the kernel itself. And so the kernel is the core of the operating system that has control over the entire computer. The kernel handles all the input and output requests, memory, all the peripherals connected to the computer, etc. And the Windows design looks like this one. So you start with your hardware layer. This is your RAM, your CPU, your physical hardware, everything inside of here. Then you have this hardware abstraction layer. This is where it will do common references to the hardware below, but you can obfuscate the different types of hardware. So when the drivers and the kernel and file system drivers, they work with an abstraction layer so that this is how you can interact with different hardware. In other words, these don't directly talk to the hardware. They go through this abstraction layer, or commonly like an API almost, so that they can talk with different versions of hardware down here. So whether that's an Intel CPU or an AMD CPU, etc., it can interact with it the similar way. Your operating system kernel, your kernel mode drivers, this will be for different drivers within the hardware itself. And then you have file system drivers. And then you have user mode. This is usually pertaining to software-based drivers. And then you have your Windows API, which interacts with all of these down below, up to your applications itself. There's two different nodes in which the CPU operates. A computer has Windows installed, and that's the user mode and the kernel mode. As you can see from here, everything up will be the user mode and down will be kernel mode. Installed applications run in the user mode, which is up here, and the operating system code runs in this kernel down below in the kernel mode. All of that code runs in the kernel mode, uses the same address space, and therefore when the user mode code runs, it is granted its own restricted address space by the kernel and along with the process created specifically for the application. So when you launch an application, it's going to give you a certain amount of resources off the hardware, be it rather CPU or whether it be a dedication of RAM, etc. Those things get allocated at the time the application requests it. Couple different file systems that you see out here today. You have the Exfat file system. This is a simple file system supported by many different operating systems now. FAT had a limitation to the number of partitions as well as the size and file sizes that it can address, and so it's not usually used for hard drives or solid state drives anymore. You used to have things called FAT, and as they say here, you had FAT16 or FAT32. They're available for use, with FAT32 having far less restrictions than FAT16. About the only time you see these anymore is going to be like on really small SD cards. Those are typically like under 4 gig. You'll see them used as FAT32 or maybe a FAT operating system. Same way with USB drives. You'll typically see those in the smaller size like that as a FAT32. But anything with like 32 gig or anything like that, you're going to see much larger either Exfat or other file system types. You have the HFS, which is commonly used on Mac computers, and it allows it to have much larger file names, file sizes, and partitions. Although it's not supported by Windows without special software, Windows is able to read data from an HFS partition. So if you plug in a Mac operating system drive into a Windows system, you can read the data, but you typically can't write that data unless you have some special software installed. You also have what's called EXT file system. This is typically used by Linux-based computers. There's a whole bunch of different operating file system types. Although it's not supported by Windows, again, Windows is able to at least read the data from these types with special software. And then you have the most commonly used one today, which is the Ntfs file system. This is by Windows, and it runs on all versions of Windows, and Linux support the Ntfs file system. The Mac operating system can only read an Ntfs partition. They're able to write to it after installing some special drivers. So for the most part, these can be used and read as long as they have special software between different operating systems, but there are some that are fairly universal that can be read by both. When dealing with the file system, there's a couple different structures. I have the partition boot sector, which is usually just the first 16 sectors of the drive. It contains a location of the master file table, or the MFT, and those last 16 sectors obtain are a copy of that boot sector. The MFT, and again, this is pertinent towards Windows file systems. So if you see MFT, we're talking about Windows. That table contains the locations of all the files and directories within the partition, including those file attributes such as security information, whether it's hidden, and timestamps with all that. That's all stored in this master file table. System files, those are typically hidden files that store information about other volumes and file attributes. And then you have the main file area, which is where your partitions are, which stores your files and directories. When you format a partition, the previous data may still be recoverable because not all of that data is completely removed, and therefore it's recommended to perform a secure wipe on a drive that is being reused. Secure wipe basically writes data to the entire drive multiple times until there's no remaining data. So if I was to wipe a drive, for example, a USB drive, I just format it, right? If I'm doing a quick format, I can still more than likely recover data from that drive. Now, if I do a full format or a secure wipe format, then what I'm doing is writing a series of ones and zeros across the entire data platform. And then I do that multiple times so that the recovery software has no chance of going and finding that data again. That generally takes a very long time to complete. Most secure wipes, depending on what you're doing them on, they can take multiple hours. These days, it's about multiple hours, whether it's a spinning disk or a solid state. You have to be careful doing that on a solid state because you have a finite number of reads and writes you can do. All right, we also have what's called an alternate data stream, and you guys will get to play with this a little bit in the labs. Ntfs stores files as a series of attributes, such as the name of the file and the timestamp. The data which a file is stored in or contains is stored in is called $data, and it's known as the data stream. And by using Ntfs, alternate data streams, or ADSs, can be connected to the file. This allows an attacker, and they could store malicious code within that ADS and then be called from a different file. So in the Ntfs file system, a file with a ADS is identified after a file name and then a colon. For example, this testfile.txt :ADS. That text file indicates the ADS, called ADS, is associated with the file test file. So you can read a little bit more about that. What we're doing here is we're gonna, like in this little test example, they echo some text to the alternate data. Here is the text, and they're gonna put that in a testfile.txt, and then you put the :ADS in there. We look at all the files, we notice that we just see testfile.txt, and if we more the alternate data, we can see that here. If we look inside of that and use the dir with the /r on it, we can see all these additional files. So what does this mean? This means that we can hide data inside commonly executed or commonly used executable files. So here we're just using a text file. This may be a fully legitimate text file, but we can stuff extra data in there and then be able to call that later. As a common user, you would just think this is a common text file, right? It doesn't even have much size. It's 0 bytes. But if we look at the alternate data stream, we notice that the alternate data stream actually consumes 24 bytes. So there's many actions that occur between the power button being pressed and Windows being fully loaded. This is the Windows boot process, and there's a couple different boot processes today. The most common one that's out there that's kind of going away a little bit is the BIOS, and hopefully you guys are familiar with what BIOS is. That's generally the process that begins when BIOS initialization phase in. That's where hardware devices are initialized. You may see a post being performed. When the system disk is discovered, the post ends and it starts looking for the master boot record. The BIOS executes the master boot record code, and then the operating system starts to load. This has been around for a very long time. Most of you guys that have been around enough probably have seen a BIOS style boot up. A UEFI is a little bit different. This is kind of within the more recent years. UEFI firmware boots by loading a little EFI program file that's stored on a special disk partition known as the EFI system partition. I'm having a little trouble with that today. So you'll notice it basically boots the same, so to speak. The only difference is UEFI is a different way of initializing hardware. You have different interaction with that hardware. And you boot off these EFI files that go directly across. Over here, your motherboard basically boots with a BIOS, and it loads those to a MBR, which is stored on your data storage of whatever type you are. So whether it's a solid state or a spinning drive, it goes through post, which is where it goes through and checks to make sure all the hardware is up and running and compatible. And then it takes you to the boot manager, which then takes you to BCD, which is part of Windows, and it starts loading all the different kernels and everything in between here. So you'll notice without having post that UEFI is typically a faster boot process, and that's why most systems use it today. So whether the firmware is using BIOS or UEFI, again, this is typically located on your motherboard itself. After a valid Windows installation is located, then bootmanager.exe, the file is there. It reads the boot configuration database, that's your BCD. If the computer is coming out of hibernation, that boot process will continue with WinResume. Otherwise, if it's being booted from cold, then winload.exe is loaded. Winload is using some kernel mode code that makes sure all the drivers for the system, whoops, let's go back here. Make sure all the drivers for that system are digitally signed. And digitally signed drivers are a big thing. You want to make sure that your code is digitally signed. After those drivers have been examined and WinLoad continues to run, then that starts the Windows kernel and sets up the how. So a computer that uses UEFI stores boot code and firmware. This helps increase the security of the computer at boot time because the computer goes directly into protected mode. And that's another reason that UEFI is used today. Again, this is protection the moment it gets into UEFI, which is protecting it during the boot process. So you can't hack the BIOS anymore. You have to hack the UEFI if you can even get in that far. And this is, again, before your operating system ever loads. During Windows startup, there's a couple things important to you, which is called the registry or the Windows registry. And those are things that automatically start applications and services. Particularly the section you're looking for is HKey local machine. There's several aspects of the Windows configurations that are stored in that key, including information about services that start with each boot. You also are going to play around with HKey current user. And this is where things related to the specific user are used. Information about services that start only in the user logs into that particular computer. So different entities within this registry locations define which services and applications will start, as indicated by their entry type. There's different types or levels of entries. For example, they could be run once, run services once, or user initiated or user init. These entries can be manually entered into the registry, but it is much safer to use the msconfig tool. And you guys will do this a little bit in your labs. So the msconfig tool is used to view and change the startup of all options for the computer. It opens the system configuration window. All right. So this is what you'll see within sysconfig, which is typically called system configuration. You'll notice that you can set different startup levels of the configuration. So a normal startup, when you boot up Windows, it's going to load all your device drivers and services. You can, sorry about that, keep hitting that button. You can use a diagnostic startup, which just loads the basic stuff. If you're familiar with Windows back in the day, this would have been like Windows Safe Mode. It's a very similar part where it's just going to load the basics and keep your services. That way you could try to diagnose something. So if you installed a bad program or a program's corrupt and causing things to crash, you could just load these base services. It was also important for checking for malware, viruses, etc. Those particularly usually fire up on boot up. And therefore, if you can get it to where it just loads the basic services, you can get to the operating system before the virus or the malware loads. You can also use Selective Startup, in which you tell it the different things that you want it to boot. And you may need to do this during troubleshooting. So during boot, you can go look at that and you can figure out which operating system you want. If you have more than one operating system installed, you can configure the bootloader, which is what you're seeing here, where you can tell it that I want certain things to boot up. How much time do I have when it's booting? And typically you don't see this today. Most computers don't run dual boot operating systems, but you can. You could have multiple versions of Windows running. You could have Windows and Linux running. You can dual boot all sorts of operating systems. But the boot manager, or the boot loader, so to speak, is kind of a menu that your screen would boot up to, and it generally has a timeout so that you could change which operating system you wanted to pick. When we take a look at the services tab, we'll notice all the services that are installed. Over here on the right-hand side, you can see their status. Typically, you'll see this stopped or they are currently running. You can click on one and you can tell them to stop or run. This is beneficial when you want to maybe clean up a computer or doing diagnostics, that kind of thing. You can disable certain things are running in the background so you can figure out what's going on, what's probably causing a bad driver, etc. Startup tab, this allows you to manage which ones will automatically start when your computer boots up. So you guys may have seen this before. You start your computer and things start firing all up at once. You typically want to disable some of those if you don't want them up on startup. You don't want a bunch of things coming up on startup because those are all allocating RAM resources. So if you have a bunch of things fire up on startup, your system can seem a little sluggish. You may have background services also that are nefarious and not supposed to be booting up that are automatically booting up in the background without you knowing it. Today, you have so much RAM on different computers, whether they're laptops, desktops, etc., that you don't see as big of an issue. But it wasn't too long ago where systems just didn't have that kind of RAM. And so your computer would boot up and it would seem to take forever. It would just grind and grind and grind. A lot of times it's because you have a bunch of things that are set up in your startup that a user typically doesn't even use during their day-to-day case. Maybe they installed some printer drivers for their brother printer or something, and those printer drivers are sitting there running in the background, and they have all these cool features. You can scan, you can make copies, etc. And if you click the scan button on the front, it automatically connects to my computer and goes. Well, that's all great, but those background services are constantly running back there, chewing up RAM resources, etc. And if you don't typically need that on a day-to-day basis, then you may stop that from automatically starting up and just start it up when you need it, when you know you're going to be clicking the scan icon or something like that. Last but not least is the little tools section, and this allows you to get access to the different tools that can be launched directly from the tab. So, a lot of times if you have a start menu or something like that, you can right click on your start menu and you'll get a list of most of these most common tools. For example, the ones that you see in this list here, but you can also go in here. So again, if you go and type in your sysconfig, it's typically what it's called. If in your search bar, you can just type system configuration. You'll get a menu that looks exactly like the one we've been looking through. We can notice that boot for my particular operating system, I have Windows 10, all my services, what's booting up at startup, and then these different tools so that you can get access to it. All of these you can type into the search bar and get directly, but this gives you a chance to just click on them and then hit launch. And if I launch Task Manager, we'll see the Task Manager that I went through earlier. So for a Windows shutdown, it's always best to do a proper shutdown for computers. You've probably heard this since the day that you've all used them, but the computer needs time to close out each application, gracefully shut down those services, and record any configuration changes before the power is lost. So during shutdown, the computer will close user mode applications first, followed by kernel mode processes, and then further shut down access to the hardware, etc. Back in the early days, if you just pulled the power cord or just held the power button to shut it off, everybody knows that one, right? Computer's not shutting down fast enough. If I just hold that power button, it shuts down great. Yeah, no, that's usually going to lead to some configuration corruption or something along the way. Back when I was doing computer repair, etc., that was great. You can do that all you want because it allowed me to go ahead and service your machine and charge money for it. But we really don't want to be there in today's section. All right. Let's see. So shutdown we were talking about. There's several ways to shut it down. You can use the start menu to shut things down. You can use the command line, write the word shutdown. You can even give a timer on this so that it will shut the system down at a certain period of time. You can use Control-Alt-Delete and then click on the power icon and shut down there as well. There's 3 different options. You can do a shutdown, which turns the computer off. You have a reboot, which will restart the system, or a restart there, powers it off, powers it back on. This is usually a cold restart. In other words, it's going to shut it all the way down and turn it back on. And then a hibernate, which is just going to save a snapshot of the current user state with the user environment, etc., stores it all in a file. And then hibernation allows the user to pick right back up where they left off very quickly with all their files and programs still open. So if you guys have laptops, etc., typically when you close that lid, this is what you're doing. You're going into this hibernate type state. And that allows you to quickly recover when it comes back up. Now, it could just be going into standby, which is another option that you'll see as well. Give me just a second here. I'm going to stop the share. Close the thread. Okay. So we talked a little bit about Task Manager and those processes. So a Windows application is made up of what's called processes. And processes in any program is currently executing. So you have things like calculator over here is a process, Microsoft Edge, etc. Each one of those processes is made up at least one thread, and they can chew up multiple threads. And so a thread is part of a process that's being executed during a one given point in time. So if you have a multi-threaded application, what that means is that it's broken out and can complete multiple things at once versus a single threaded application where it has to go crunch data, make you wait, and then come back. Multi-threaded applications allow you to do multiple things at once. It's the easiest way to explain that. So to configure Windows processes, you can search for them within the Task Manager, which is what you see on the screen. The Processes tab is going to give you what each one of those are. It'll tell you how much of the current CPU it's chewing up, as well as the RAM resources, disk, as well as your network here. And all those threads are dedicated to a process that contain the same address space, which means these threads cannot access the address space of other processes. That prevents the corruption of other processes. So you can't do process hijacking, which allows you to fire up Microsoft Edge, but then say I fire up a command line over here, attack that process. It's in a completely different address space, and I have no access to that address space. However, there are ways to attack that address space and gain access to it. Some of those processes in Windows are running as services, and so therefore they're running all the time. The services basically mean that they're going to start up with Windows, maybe necessarily, but they're usually background services. They don't typically have a GUI that's in front of you all the time, like say Microsoft Word or Excel or something like that. And typically they're in the background to support the operating system or maybe other applications. They have a long-running functionality, such as a wireless or access to an FTP server. For example, here you have Windows Defender Firewall running in the background. You have an event log collector and manager so that it can collect logs from different file or different applications, etc. So to configure those Windows services, you can just search for those. You'll get this Windows Services panel. It's pretty simple. Just be careful when manipulating these as the settings. Shutting down a service generally has adverse effects on applications and other services. So if you go and actually look at yours, I can just go in here in my search and I'll type services. and I would get my services running in the background on this particular system, I would want to be careful about some of these services about, what I shut down and don't go. So you can see if I click on status and we'll sort it, I have a bunch of background running services on this particular system. Some of these are legitimate and I may want to use them. So for example, Plantronics update, that's a service that deals with a headset that I have running. And so it's a little service in the background that constantly checks for updates. You might be familiar with the Windows one, Windows Update, and those type services running in the background. But there's a bunch of these different ones along the way. Typically, if you shut one down that was required to be running, you'll start to get a bunch of errors running in the background. Every now and then, the applications start smart enough to go ahead and fire it back up, but that isn't always the case. All right, and I apologize if I'm going through this rather quickly. There's a lot of information on this Microsoft Windows section, so we're going to try to get through as much as I can today. And then we may come back and recap some of this on Thursday. The Linux section is not near as thick, if I remember right. All right, so memory allocation and handles. The virtual address space for a process is a set of virtual addresses that a process can use. That virtual address is not the actual physical location in the memory, but an entry in a page table that is used to translate that virtual address to a physical address. Each process is in a 32-bit operating system, supports a virtual address space that enables up to 4 gigabytes. So if you remember when you had the old 32-bit operating systems, the max amount of RAM that you could have in a system was generally 4 gig because that's all it could address. And 4 gig of RAM was a lot of RAM back in the day. That seemed like such an enormous amount of RAM. I believe the first machine that I had 8 meg of RAM, and that was pretty good. I eventually upgraded that to 16, and then I had systems that had 32, and man, I thought that was just a lot of RAM. I could do a lot of things with a lot of big applications back then. But that slowly took off, and you got up to 128 and then 256, and I started building systems that had 2 and 3 gig of RAM, and that was just, you could run so much on those systems. But then eventually you capped out at 4 gig. And so now we have 64-bit operating systems that have a virtual address space of 8 terabytes, which means you can have up to 8 terabytes of RAM within a 64-bit operating system. Now you can actually get beyond that within server platforms that are designed for more operating or for more address space, but 8 terabytes of RAM is a lot of RAM. Typically, most desktop, laptop type systems today, you probably see anywhere from 8 to 32 gig of RAM. Some of your higher performance gaming systems or bigger laptops like the one I have here, they typically have 32 to, I think my system can handle up to 128 gig of RAM. So if we look at this particular one, I have 64 gig of RAM in this one, and it's capable of up to 128. But note that it is using a Xeon processor. And to get those higher levels, you typically are not using desktop operating system or desktop processors. So your Intel Pentium processors or your all the Core i5s, i7s, that kind of thing. Now, typically you won't see that much RAM available to the system. They cap out around 32 to 64. Each user space provides a private address space, and separate from the user, another user's space processes. This user space process needs to access kernel resources, and therefore it must have a process handle. And as a user space process is not allowed to directly access these kernel resources, the process handle provides the access needed to the user space without direct connection to it. So there's a bunch of obfuscation, particularly within the newer operating systems, so that people can't directly access the core or the kernel, thereby overriding or stealing data from another process. So if I wrote a program to go say, hey, go figure out what's in the Microsoft Word process right now. So if I write a background service program, right? And I say, just monitor for Microsoft Word. Once you get that allocated, I want you to monitor that address space. I can't do that. I can't go and look at another application's address space directly on the system. And I certainly can't do that within another user space. So if user Jason Zeller is logged into this system, I can't come in as, you know, Sam over here and figure out exactly what Jason's running in real time and have access to that user space. So a great way to look at this is a tool called RamMap, and we'll take a little bit further look at this in some of your labs. It's part of the system internal suite, which is a great suite of tools. If you guys haven't played with that, again, you will in your labs a little bit, but I encourage you just to download it and put it on your own system. It's made by Windows. You just do a Google search for Windows Sys Internal Suite, and there is a whole lot of tools that are included in there. Several of them are pretty interesting. There's ones I use on a daily basis, running in the background, etc. But this will give you an idea of where everything is being allocated on a system. And if you're one of those tech help desk type users, then you'll be wanting to look at some of this type of information in more detail, more than just what Task Manager tells you, so to speak. And so it will tell you how Windows has allocated that system memory to the kernel, to processors, to drivers, and applications themselves. Okay, so we briefly talked about the Windows registry. Earlier, we talked about HKey current user and HKey local machine. However, the way Windows operates is it stores all the information about the hardware, applications, users, and system settings, etc., in this large database known as the registry. And that registry is a hierarchical database with the highest level known as the hive. And again, these are keywords because this will be on your exams. Below that are keys followed by subkeys. So understand that hierarchy. You have the hive at the top. It's a hierarchical database to the registry, which gets to keys, and then you have subkeys from the keys themselves. Values are stored data that are stored inside the keys and the subkeys, and a registry key can be up to 512 levels deep. So you can have this big hierarchical chain that goes all the way down. The following table lists the top 5 highs of a Windows registry. So we talked a little bit about current machine. This is, or a current user rather. This is all the stuff relating and concerning the current user that's logged in. You have HKey users. This is about all user accounts on the host. You have classes root, which will have object linking and embedding. OLE is what you'll typically refer to those as, registrations. It allows users to embed objects from other applications into a single document. You have local machine, which has all the current system related information, and then the current configuration, which is information about the hardware profile. So if you ever have to dive deep into the Windows registry, these are ones that you will commonly see, with the current user and local machine being the top ones that you would use. Every now and then you may need to dip into these other hives. Okay. So new hives cannot be created. You can only create keys and values within the hives themselves. And you can create those, modify them, delete them, have an account with administrative privilege. To do this or use this tool, we use what's called Regedit, and you can type this simply into your search bar and get the Registry Editor. And that usually needs administrative privileges, so you'll see that pop up on your screen. And so a registry editor, like on this particular system, looks like this one. Notice I have my top tier hives up here, and then we can go further into these different systems. So there's different hives. You can see where you break into SAM and software and system. And remember, this can go up to 512 levels deep all the way through. You want to be very careful when using that tool. You usually have a specific reason to go to that tool, because even minor changes in there can have massive or even catastrophic effects. It can keep your Windows system from even booting anymore. So typically the people that are going into registry have a very specific key that they need to change, and you don't want to mess around too much in there if you don't know what you're doing. All right, so the navigation of that registry is very similar to like a Windows File Explorer, as you saw. The left-hand side will navigate those hives, which we can see over here on the left. And then the path is displayed across it. So if I open this and go to software, you'll notice that you see this path go all the way across. They say at the bottom, but it can also be at the top. It just depends on this layout, as you see here. Registry keys can either contain a sub-value or a key or a value. So you'll notice here, these are sub-keys, and then these are values over here at the right. Each one of these values has a different type, as you can see over here. So this one is a D word, this one is an SZ, etc. And what those type means are, if they're a binary, it's either a number or a Boolean value. If you're not familiar with Boolean values, Boolean is either true or false, basically on or off, zeros or one. You can have other numbers that are set there as well. You can have numbers greater than 32 bits are going to be D words. And so, for example, if we looked at this one here of log pixels, if I double click on it, you can see the value is 90, and they're usually set up as a hexadecimal. And so you can see that over here, this is the hexadecimal value of 144. So you can modify this, you can modify it in binary if you want, and this is a hex editor that allows you to see that directly. And you can also have string values, which are those SZs that we saw before. And so a registry contains this activity that a user performs on a day-to-day use. It includes the history of hardware devices, including all devices that have ever been connected to the system, including the name, manufacturer, and serial number. So if I plug in a USB drive, the registry is going to record the manufacturer of that, the serial number of that, etc. And as a cybersecurity analyst, I can go into the registry of a system and start looking at all the USB drives that have ever been plugged into the system, which can be handy because you can figure out when they were plugged in, etc., which is like looking through the logs, only you can comb through and grab a whole bunch of extra data inside of there. So if something nefarious happened, you can go back and look in the registry and saw what happened at a previous date and when those changed. So you guys are going to go through a couple different labs, and I'm going to assign those here. You'll see them after class today, listed on the system. One of the main ones is being able to go through and explore, etc. Now, these ones that are listed here are going to use the NetLab system. I will send out more information about the NetLab system here today, and so we'll get you enrolled in there. For this class, if you, and again, I'll have a short little recording for the NetLab side of things, but if you've ever used NetLab before, you will not use that login for this class anymore. This will actually get launched directly from Blackboard. So you guys will click on a link in Blackboard to get access to those labs, and you will not use your other login for NetLab. As a matter of fact, it will automatically log you in, create you, and go from there. So I'm going to get that all set up. It's kind of a new thing that I'm doing just in my classes this fall that helps integrate with the LMS, and that it's a kind of a cool new feature. It takes one less thing for you guys to remember. No more passwords for NetLab to remember, etc. You can still schedule and go on through. And again, I'll do a demo of that probably on Thursday when everything's set up and ready to go. I was waiting for an update on the labs, and I haven't really seen anything, so I'm just going to put up the last labs that were out there, and once there's an update to these, we can do those. But for the most part, they're about the same. So anyway, you'll go through, you'll kind of go through and look at the processes, the threads, the handles, and the Windows registry. Feel free to take a look on your own local system if you choose to do this. But I encourage you to do it within our lab setup, because if anything goes wrong, it reverts itself back and you're safe. So if you accidentally delete something in the registry or purposely delete something in the registry to see what happens, that's best done in the lab environment. Don't do it on your main machine. Okay, let's see. We go to about 10:15, so I got about 15 more minutes here. So we're going to cover the Windows configuration and monitoring. You've probably seen this multiple times. When you want to run a program, somebody says, oh, you have to run that as administrator. You want to be very careful about running as administrator. There needs to be a good reason for that. And the reason is once you launch that application as administrator, it now has administrator privileges. So you can do things within that application that you wouldn't normally have access to unless you approved it. But once you approved it right off the bat, now it can go and run things that you never intended for it to do. So you got to be careful about giving things administrator privileges. And so there's two different ways to run or install a software that requires administrator privileges. You can right-click on that file, and you can run as administrator, as you can see here when they're trying to run Notepad. The other way to do it is search for the command prompt. You can right-click on command prompt and run as administrator, and then every command that you execute from within that command prompt is now being done with administrator privileges. So including installing software, launching software, etc. So you really want to be careful when you click on this run as administrator. So many people do it today without second thinking about it, and it's because they've never been infected before or had their system hacked, and they've never realized how bad and how powerful this does when you click on it. And Windows has done a great job over the last few years of further protecting people. It used to not be a big deal. Everybody just logged in as administrator, and then they didn't have to click on it 900 times. Now they're really trying to limit making sure you do that and making sure the user understands what they're clicking on. All right, so some configurations is local users and domains. When a new computer is started for the first time or Windows is installed, there's a prompt to create a user account, and that's known as a local user account. It's local just to that computer system. That account creates all the customizations, access permissions, file locations, and other user-specific data. To make administration of users easier, you have what's called Windows groups. So they put a bunch of users into groups, and those groups will have a name, and then there's a specific set of permissions associated with that group. When a user is placed into a group, the permissions of that group are given to the user. So you can have individual user permissions, you can have group permissions, and then you can have permissions on top of that. A user is placed into multiple groups to be provided to different permissions. When the permissions overlap, certain permissions, like explicitly deny, will override all the other permissions by a different group. So I, Jason Zeller, can be a part of the administrators group. I can also be a part of the workers or the help desk group, etc., that may have different permission levels on different systems. There are many different user groups that are automatically built into Windows that are used for specific tasks. So for example, if we were to look at our local user group management, so you can type this tool in on your search bar and you'll get access to it. So if I pull that one up here, and I may or may not have access to this one, we'll see. Doesn't look like I do right off the bat. And that's because this is a campus system, so they probably locked me out of some of that. But Windows also uses domains to set permissions. And so a domain allows you to have a network service where all the users, groups, computers, peripherals, security settings are all stored and controlled at a database. And this is typically within a Windows database. You have what's called Active Directory, and we'll talk about that. So we also talk a little bit about CLI and PowerShell. So you guys have opened up the command line interface of cmd.exe, but there's another type of that called PowerShell. Within the CMD, the file names and paths are not case sensitive by default. So different than Linux, right? Linux is all case sensitive, where Windows, it's not by default. Storage devices are assigned a letter for reference, and this can be followed by a ://. Commands have software optional switches, is what they call it in Windows, with a // as you can see here, the // and then you have to delineate between a command and a switch option. You can use a tab key to autocomplete commands for both directories and files referenced. And then Windows keeps a history of the commands that are used during the CLI session. You can access those by pressing the up arrow key or the down arrow key. And you can switch between storage devices by typing the letter of the device followed by : and then you get to the enter. So you guys will use these in the labs as well, but we've demonstrated this before. So we can see I'm on my C users JL Zeller. If I do a listing of all the different hard drives on my system, I can see if I wanted to change to my D drive. I'm now on my D drive, and I can do dir, and I can see all the different things that are on my D drive. I have an E drive. I can see all the different things that are on an E drive, etc. And you can switch between those drive systems. You have another environment that's called the Windows PowerShell. And what's nice about the PowerShell is you can use it to create scripts that automate tasks that are similar to the CLI and they're unable to create in there. So PowerShell is in the most recent versions of Windows, and it's become extremely popular. If you can learn to write PowerShell scripts and such like that, you can do a lot of different things. So it's integrated within Windows now. It's like the CLI, it can run with administrative privileges. And you have what's called Commandlets or CMDlets. These are little things that perform an action and return an output of an object of the next command that can be executed. You have PowerShell scripts. Those have an extension of usually PS1, and those contain PowerShell commands that are all executed in a script fashion. And then you have PowerShell functions, and those are little pieces of code that can be referenced with inside of a script. So you guys, by taking this course, you've probably already taken my Python course, and this is like having a version of Python, but it's based specifically for Windows, and that programming language is called PowerShell. So you can get more information. You can type help inside of a PowerShell, and you can run these little commandlets. So you can see things like get help, and you can run all these different commands all the way through if you want detailed information, etc. There's a whole lot of different commandlets that you can learn in the PowerShell. We talk about the WMI, which is the Windows Management Instrumentation. This is used to manage remote machines and remote computers. It can retrieve information about system components, hardware, software statistics, etc. It's a pretty popular tool, especially if you are in a network environment and you want to remotely manage another system. You can use administrative tools, and then computer management is a good way to load it from control panel. And you can expand the services and applications tree, and then the WMI control with properties. And so you can see a GUI version of this here. With WMI control, you can connect out to a remote system and get that information. So you can get general information about the local computer, like you can see here. You can do backups and restores. You can do settings to configure some of those access, and then advanced will get you a default namespace. All right, so on the command line, we have a command that's called net, and net allows us to get a bunch of different information about the system. Prior to all these nice GUI features that you see in Windows, a lot of the power comes from the command line. And typically when you get access to a remote system, say you are ethical hacking or you're a not NetLab administrator, but a network administrator, you do a lot of things from the command prompt. You don't usually want to click through a bunch of GUI to do things that you can do with a real quick command. So the net command is typically used for administration and maintenance of the operating system. You can turn things off and on real fast. It supports many subcommands that will follow it, and then usually has a bunch of switches after that to turn different things off and on. And you can run the net help command here to get some output to see what all the different things that you can run. And so things like net accounts is going to allow you to set password and login requirements for users. Net session lists all the different sessions that are connected to the system. It's a great way to see or parse this output data to see if somebody's connected that shouldn't be connected to the system. Net share is going to do creating, removing, and managing shared resources. Net start and stop will deal with turning off and on network resources and services. Net use allows you to connect, disconnect, and display information. And then net view allows you to view all the computers and networks on a network. We already talked a little bit more about Task Manager, but this is another resourceful tool for administrators to see what's all going on. Notice you have 7 tabs across the top here that will bring in more detail on each one of these. So you have the Process tab, which lists all the programs and processes that are currently running. You also see the CPU, the memory, the disk, and network utilization we talked about. And those can be examined and get more details, and then you can end it if it's not behaving correctly or stalled. So if you've had a program that's no longer responding, you guys have probably seen that from time to time. Usually they tell you to open up Task Manager and in that task, and then I'll close the program and then you can relaunch it. The Performance tab allows you to get statistics, including all those things that we talked about before. And clicking on the left pane will show you statistics on that particular item in more detail. You have App History, which is the use resources of the application over time. And you can do show history for all the processes, which will give you a much more detailed information. During startup, this will tell you what applications are set up for the startup, and you can choose to right-click on those and disable them if you want to. You have the Users tab, which is going to list all the users that are logged into the system and all the resources being used by that user. The Details tab is going to give you additional management options for those processes and setting a priority to make the processor devote more time or less time to that particular process. There's a useful feature in there called Analyze the Wait Chain, which allows you to show any processes for which the processor is waiting. This allows you to see if something's stalled out or if it's just simply waiting there. Services will show you a PID, and there's one term that you want to memorize, which is the process ID. That gives you a number and typically a short description of what's going on, along with the status of whether it's running or stopped. At the bottom there, there's a button to open the services console and provide additional management of that. And we looked at those services earlier. You also have what's called Resource Monitor. This is a more detailed version of what you see within Task Manager. And so what you can see within Resource Manager, that you may find something that's acting erratically, and you can come in here and see it. It may be suspended. It may have a bunch of, be jumping around quite a bit, launching and closing a bunch of different things. And so you can track that down here. We talked about Task Manager and Resource Monitor. These are general overview things. So the CPU is always talking about PIDs, which we talked about a little bit before, the number of threads it's consuming, which process is using, and the average CPU load usage of each process. The memory will show you all the statistics about RAM, etc. Disk, your read-write statistics, is it how fast it's reading and writing. And then your network tab will tell you how much it's network consuming there as well. I tell you what, for the networking portion of this is probably where we will pick up on Thursday. Again, I know I covered a bunch of material here. There's quite a bit in the Windows section. So we got a little over halfway on it today, and then we'll cover the rest of the Linux section on Thursday. I know I covered that in fast detail. Does anybody have any questions over the material I covered so far?
Just about the dates, because usually we do Monday, Wednesday. If you want to change that over to Thursday, I mean, by all means.
Nope.
Just making sure that that's what you were doing.
Nope, you're right. Wednesdays. Sorry. So for everybody that's listening to the recording, Wednesday, not Thursdays.
All right, cool.
Yep. Wednesdays, same time. I've got so many classes this semester, I got a little backwards. Anybody else have any other questions? All right, I'm going to end this recording.